So let's take a look at taking care of these square roots when everything doesn't clean up. So if we look at something like the square root of 8, we've already said how for 8, we can break that up. We said 8 was 2 times 4. That 4 is 2 times 2. And so our 8 ends up being 2 times 2 times 2. So our square root of 8 is the square root of 2 times 2 times 2. Our index is a 2, which means we need sets of 2s to pull things out. And so here I have a set of 2, but now I have a 2 that doesn't have a partner. Because that 2 doesn't have a partner, that means I can't pull it out in front of the radical sign. So this set of 2s I get to pull out in front of the radical sign, but this 2 I have to leave back behind because it doesn't have a partner. So I leave it back behind underneath the square root, and that's how we clean that up, where we're not typing it in the calculator and getting an approximate answer. This is an exact answer. Whenever we work in these problems, we're always going to give the exact answer. We're only going to give an approximate answer where we'll go to the calculator when we can't get the exact. So this would end up being our answer for that one. Now let's take a look at it, how it would look with the variables. So let's just do y cubed. My y cubed, square root of y cubed. My square root of y cubed is just y times y times y underneath that square root sign. And so just like over here, I have a set of 2 y's, and I'm looking for sets of 2 so that I can pull and write one of those out in front of the radical sign. And then this y is still left back behind because it doesn't have a partner to be pulled out in front of the radical. So this is my answer here. So see, it works the exact same, but we need to take a look at how that would be if we have something bigger than a y cubed. We don't want to write out y to the 15. We don't want to write 15 y's. So when everything cleaned up before, we said we were going to take that exponent, we were going to divide it by the index. And so when I take my 3 and divide by 2, I don't get something that goes in evenly. 2 goes into 3 one time, but there's a remainder of 1. That one time that it went in, this is how many we're taking out. That remainder is how many we leave behind. So this one is from here, and this one that's left here is from there. So that's how we're going to work it with the exponents. So now we have to put this together and simplify one. So let's do an example, and then we're going to summarize everything. So the example is just going to say simplify. Our first example is the 5th root of negative 64 y to the 18th. So I need to try to break up my 64, and so I can get something times itself 5 times. So let's start breaking our numbers up. 64, well, it's 8 times 8. And we know that each of those 8s will give us 3 2s because we just did that. The other thing we know is there's a negative inside of this radical, and it's an odd index. So I'll be able to write a negative out in front. And then I don't have to deal with the negative once I pull and write the negative in front of the radical. So I have 6 2s and then my y to the 18th. I'm looking for sets of 5. So here's my 1, 2, 3, 4, 5 2s. That lets me write a 2 in front. And I'm going to write the 2 behind the negative sign. And then I still have to deal with that y to the 18th. So this 2 stays here. And then I have my y to the 18th. So for my y to the 18th, I'm going to take the 18. I'm going to divide it by my index of 5. 18 divided by 5. So 5 goes into 18 3 times, because 5 times 3 is 15. And if I take that 15 and subtract it from the 18, I will have a remainder of 3. So that means I'll be able to take 3 y's out and leave 3 y's in. So negative 2y cubed, fifth root, 2y cubed. And this will be my answer. So let's take care of another one. The fourth root of 162, x to the 7th, y to the 20th. So we have to figure out that 162. Let's do a 2. 2 goes into 162 81 times. That 81 is 9 times 9. I'm looking for 4 of something, and I still don't have it. So my 9s I can break up to 3 times 3. So this 162 will be 2 times 3 times 3 times 3 times 3. And I'll be able to get something to work off of that. I'm looking for sets of 4. Here's 4 3s. So I'll be able to write a 3 out in front of the radical. Now I have to take care of those exponents. So for that x to the 7th, I will take the 7 divided by the index of 4. 4 goes into 7 one time with remainder 3. And for the y to the 20th, I'm going to take the 20, divide by 4, and it goes in 5 whole times with a remainder of 0. So on that x to the 7th, I'm pulling out 1x in front of the radical. I'm going to leave 3 x's inside the radical. For the y to the 20th, I'm pulling out 5 y's in front of the radical, and I'm leaving none of them back behind. And that's our final answer. So it's not that bad. Let's summarize some of this up. So we said that's the radical. The number that goes here, we said that's our index. The stuff that goes underneath the house, underneath the radical sign, is our radicand. We said a square root is that. which means that your index is 2. A cube root has an index of 3. When we're simplifying our radicals, the index tells us how many we need in a set. So that we can write 1 in front of the radical sign, whatever. That's just a number sign there for whatever index you have there. We said for the exponents, oh, let's go back some. We said when we had an even root and you had a negative number, we said that was not a real number. We called it imaginary. We said we're going to go back, we're going to go later and learn about the imaginary. When it was odd with the negative, we said we can take the negative and write it in front. We said for exponents, we're going to divide the exponent by the index. The number of whole times it goes into it, we take that out, and the remainder is what we're leaving behind. And so this is pretty much what we're doing. Oh, I didn't mention the irrational number. Our irrational number. Remember, our example is the square root of 7. And that's because the radical didn't clean up to a whole number. Actually, I'm going to write to an integer. Because I have the cube root of 7, it's not going to clean up either. So as long as it's giving us something like a 2, a -2, a 3, a -3, those are okay. It's just when we can't clean those up to something else. Okay? And that is our first look at our radicals.